Good afternoon and welcome to lecture 7 of ECL 706. If you remember, in the last lecture we had briefly discussed some of the issues pertaining to formwork design. We discussed the various requirements of formwork design, for example, the safety, the stability, the prevention of collapse, prevention of overturning. These were some of the requirements. Then we discussed what kind of design approach we follow for formwork design. Although in real life you find that formwork design follows the same principle that you follow for design of permanent structures. The treatment may not be that rigorous depending on the situation. Sometimes you may like to work with even thumb rules. However, if the consequences of failure is extremely high, in such cases you may have to design and analyze things in a quite rigorous manner, just as in case of a permanent structure design. We discussed various loads acting on the formwork. We divided it into three categories primarily. First one was the dead load. We discussed what kind of dead loads are expected on any typical formwork, and then we had started discussing imposed load. In imposed load, the main thing that we learnt was how to calculate lateral pressure. So, lateral pressure is one of the important consideration in analysis and design of formwork. We learnt one method that we called it as Syria method of calculation of lateral pressure. Today in this lecture also we are going to learn few more methods for calculating the lateral pressure. If you remember, we had covered this Syria method of computation of lateral pressure. We are discussing right now how to calculate the lateral pressure which is acting on to your formwork surface, formwork materials due to the fresh concrete. Now in today's class we are going to learn three more methods for computing this lateral pressure. We are going to learn ACI method, which is American Concrete Institute method of lateral pressure. Second, we are going to learn Indian standard, how we calculate here in India the lateral pressure. Then third, we are also going to learn a DIN standard. They are also widely used standards. So, we are going to learn these three methods starting with ACI method of computation of lateral pressure. Now, in ACI, if you look at the formula or else I will write it here, the ACI method gives you the formula to calculate lateral pressure like this. P is equal to coefficient Cw and another coefficient Cc, this is Cc, multiplied by 7.2 plus 785 R divided by T plus 17.8. This is the formula. Remember, we are discussing ACI formula, and this formula is valid for calculating the lateral pressure for column. This formula is for column, right? Now, this P which you have calculated should not be more than a P max of, should not be greater than P max equal to 150 multiplied by Cw Cc, and it should not be less than 30 Cw. It should not be less than 30 Cw. In any case, it cannot exceed W into H. In any case, the value P that you calculate should not be more than this. Do you understand this technology class? Because this WH is nothing but assuming that it's a liquid, complete liquid, the pressure in any case is not going to exceed your WH or gamma H, whatever is your notation. So, no matter what value of P you are getting out of this formula, this in no way is to be greater than WH, and its range you can see is like this. It should be between 30 CW and 150 CW Cc. Do you understand this technology class? Fine. So, this is as far as column is concerned. Similar formula they have given it for wall also, and for wall I will write it on a different sheet. It is given like this: P is equal to CW Cc multiplied by 7.2 plus 1156 divided by T plus 17.8 plus 244 R divided by T plus 17.8. So, this is the expression. Here again with maximum of 100 CW Cc and a minimum of 30 CW, and in any case it cannot be greater than, in no case greater than WH. In no case it has to be greater than WH. So, this is in case of wall, this is in case of wall. So, these two expressions are also quite frequently used for computing lateral pressure for columns as well as for wall. Right. Now, here you might have noticed I am using some notations which are different than what we used in case of Syria. CW is basically a unit weight coefficient, unit weight coefficient, unit weight coefficient. I will give you its value. Cc is again chemistry coefficient depending on the cement specifically. This is chemistry coefficient, right. I will give you these values. Have you noted down these expressions? I am not getting your voice. Can you just switch on your mic, please? Okay. So, if you look at this particular slide, computer slide, you can note down what various terms stand for. For example, P in this expression is for lateral pressure, and it is to be measured in kilonewton per meter square. Remember, the units are very important in case of empirical formulas. They are also important for other cases, but if you are using empirical formulas, unit has a great role to play. So, whatever units are specified, be sure that you use the same units that is given in the formula. Then when it comes to small h, it is the depth of concrete from the top of placement to the point under consideration. That means at what height you want to measure the pressure. So, this is what h means here. W is unit weight, again in kilonewton per cubic meter. Capital R is your rate of displacement, or rather rate of placement in meter per hour. T is your temperature of concrete during placement, it is in degree Celsius. T is in degree Celsius. Now, I have to give you the table which can give you the values of CW and CC. So, here are they. This table gives you the value of both CC as well as CW. Now, if you look at the first column, it gives you types of blends used, basically the cement type. So, for first type of cement, that is the blends without retarders containing less than 70% fly ash. Can you read this slide, technology class? So, depending on the type of cement used for preparing the concrete, CC takes anything between 1.2 to 1.4. CC takes a value of 1.2 to 1.4, and CW is again depending on the weight, unit weight specifically. So, if the blend is used without retarder and containing less than 70% fly ash, they have given you the expression of CW as 1 minus W by 23.2, but less than 0.8. This is the expression that you use when your blends are without retarders containing less than 70% fly ash. So, for this case you use this expression to calculate CW, 1 minus W by 23.2, and it has to be less than 0.8. Likewise, for different types of blends, these value of CW varies, and accordingly you can use calculate a CW for different types of cement. Now, we will move on to Indian standard method of computing this lateral pressure. So, now we discuss this Indian standard. In India, there is a code IS 14687, Indian standard 14687. This was published in 1999, right? So, this gives you this gives you the procedure to calculate the lateral pressure. Now, unlike Syria and ACI method, IS code gives you various curves. It gives you various curves. I will show you one curve. It is shown in this particular slide, computer slide. If you just focus on this computer slide, it gives you a figure like this. In this figure, on the x axis you have rate of placement. This is measured in meter per hour. So, on your x axis you have rate of placement, on your y axis you can read the pressure, it is in kilonewton per meter square. There are different curves corresponding to different temperature of concrete, starting from 5 degrees Celsius to 40 degrees Celsius. So, the top curve is for 5 degrees Celsius, the bottom most you can see it is for 40 degrees Celsius. So, if I just try to draw it on this piece of paper, it is something like this: rate of placement, as I told you, this is in meter per hour, this is your pressure, it is kilonewton per meter square. So, you have different pressure values here, you have different rate of placement. Now curve is something like this. Something like this. So this one is for temperature 5 degree and the bottom one was for 40 degree Celsius. So at any temperature you want to measure what would be the anticipated pressure against a given rate of placement. You just have to suppose this is the rate of placement at which you want to pour your concrete, and temperature is, let us say, 15. Suppose this curve is for 15. So you just need to read this value. You just need to read this value in order to calculate the lateral pressure. Is it clear to you, technology class? Okay. Now these figures are for 33 grade of cement. These figures are for 33 grade cement. There are different grades of cement, 43, 53 and so on, right. The curve given in this IS code is for 33 grade cement, right. Besides this, the mix design has been made assuming that you are going to use 350 kg per meter cube cement. So cement quantity also has been fixed at 350 kg per cubic meter. So for producing 1 cubic meter of concrete, it is assumed that you are going to use 350 kilograms of cement. So 33 grade cement and quantity also is fixed. Now they have also assumed workability. For producing this curve, they have assumed that there would be medium workability. Workability would be of medium category. Workability would be of medium type. Now this is requirement 1, this is 2, this is 3. So corresponding to these 3 requirements, they have produced these figures. Now suppose you change the grade of cement, you suppose change the weight of cement for every cubic meter, that is the quantity of cement every cubic meter of concrete, or you change the workability. Then you have to apply certain correction factors. So these correction factors I will tell you which needs to be applied for cement. If you are using less than or more than this, if you are using cement of different grade, and if you are using anything but this medium workability. Okay. So corresponding to, let us say, 400 kg, suppose you have designed a mix which is 400. Yes, yes. How it? Based on its compressive strength, 33, 43. Have you not been taught these grades? They have different grades of cement based on the based on the compressive strength that they get after 28 days. Okay. So what kind of classification you have for your cement? How do you classify your cement? Direct compressive strength. Okay, these things have not been discussed in concrete material class. The different grades of cement, how do they get classified?
We are classifying just by the compressive strength, saying C25, C30, C35, something.
No, that is no, that is the concrete grade you are specifying. Are you talking of this is concrete grade M20, M25? This is different.
Yes, yes.
No, this is concrete grade. This is, remember, cement grade. Is it clear? This is cement.
Yeah, yeah. But we are classifying OPC, PPC, ordinary Portland cement.
But
Ordinary Portland cement.
in OPC there would be different types. So how do you classify A, B, C, D? So this is based on compressive strength again. So A may be 33 grade, B may be 43 grade, C may be 53 grade. So here again based on some strength of cement. I will request one of my colleagues, maybe Dr. Sasank Bisnoi, to give you more information on these cement grades. Is that okay? Okay. Okay. So remember, these grades are cement grades I have talked. So this is 33 grade cement, and this 350 kg is the quantity of cement per cubic meter. This is the quantity of cement. So these curves have been drawn for 33 grade of cement and a cement quantity of 350 kilograms per cubic meter of medium workability. Now we were discussing about these correction factors. You can just have a look at this particular table. Yes. What do you want? How you can measure? Meter per hour. That R you want to measure? Is this what you want to measure? How to measure R? You are saying meter per hour, this you want to measure?
Yes, how can we measure concrete
It is simple. That day I told you, suppose you have a wall to be done. Let's say this is a 10 meter wall, 300 millimeter width, right? And let's say height is 4 meter. Okay. So calculate the quantity. 10 meter by 0.3 by 4. Okay. So this is 3. This is 12 cubic meter. That means 12 cubic meter has to be filled in order to complete this whole wall. Now suppose meter cube is there, yes. Now this meter cube, if you know how much time you will take to fill it up, you can convert it. I had given you two problems, one in which I had given you this value and I had given you the time. Rather, I had given you the rate of pour. I had given you, let's say I tell you that you are doing at a rate of 3 meter cube per hour. Suppose you have a mixer machine which produces 3 cubic meter per hour. Is it clear? So how much time you will take to complete this pour? 4 hours, okay. But your empirical formula wants you to give it in meter per hour. So 4 hour you take to fill 4 meter. So what is your rate of pour? R becomes 4 by 4, which is 1 meter per hour. Is this clear?
Okay, that's clear.
Clear? Although you may be talking it in terms of meter cube per hour, but just because in empirical formula I want to put in meter per hour, I have done like this. Is it clear to you now?
That's clear.
Okay. Now if you just look at this particular computer slide, it gives you the correction factor for workability. This is as per Indian standard. Remember, the figure which I showed you was used for medium workability. So against that medium row you find the value 1 1 1. Do you notice this? Why we have 1 1 1 against this medium degree of workability? Because the reference is medium. Now anything other than medium you have to apply the correction factor. So if you have low workability, the pressure would be high or low? Low workability means stiff concrete. Stiff concrete. So your pressure would be high or low? Yes, technology class. Suppose there is one free flowing concrete and there is one stiff concrete. Which one will have more pressure? Which one exert more pressure? Okay, answer this question. You have a normal concrete and you have a self compacting concrete. Self compacting concrete, you understand? Where the slump is very large, very high, it just flows like liquid. So which one will exert more pressure, normal concrete or self compacting concrete? Yes, definitely, because it would exert more pressure because there you have more workability. So it will try to flow. So the more it flows, the more pressure it exerts. So now if you look at this table, you will find that if the degree of workability is low, that means if the concrete is stiff, the pressure would be low. So that's why your coefficients are less than 0.1, 0.7, 0.8, corresponding to 1 meter per hour rate of placement. So is this table clear to you now? If you look at it, for high the correction factor is 1.1. That means pressure would increase if your workability is high. If your concrete is more free flowing, it would exert more pressure. So you have to multiply it with value more than 1. So this is what it gives you. Is this table clear to you? Okay. Now I show you other correction factors. One is for cement content. Just a while ago I told you that the figures are valid for 350 kg per cubic meter cement content. Now for every 50 kg increase in cement content, rate of placement of concrete may be reduced by 0.5 meter per hour. So now you can find that the rate of placement itself have been corrected, and accordingly you can apply the correction factor. Similarly, for density of concrete, the fourth category, if you see here in this, One was this quantity, then this is the grade, this is workability. Another thing is the concrete density assumed for those curves are 24 kilonewton per cubic meter. So, if your concrete density is changing from 24, you have to apply correction factor again. Is this clear? What this means is like this. Suppose there is one concrete which has a density of this, another concrete which has a density of this. Which one will have more pressure? Which one will exert more pressure? Definitely this one, because your formula says WH. So, if W is increasing, pressure would also increase based on that simple logic. Now, the figures which I showed you are valid for 24 kilonewton per cubic meter. Anything other than this, you have to increase or decrease on a prorate basis. Suppose it is 26, so pressure would increase 26 by 24 into P. Is this clear? Suppose instead of 24, you are using a concrete of 26 kilonewton per meter cube. So, your revised or the corrected pressure would be 26 by 24 into P. Is this clear to you? Suppose you are using a low density concrete 22 kilonewton, so it would be, the pressure would be low compared to 24 kilonewton per cubic meter. Is this clear to you, technology class? Okay. So this is what some of the correction factors recommended by Indian standard. There are two more corrections. They are shown in this particular slide. As I told you, for cement other than 33 grade OPC, the code recommends suitable correction factor in the P max, maximum lateral pressure. The value of P max can be increased or decreased depending on the relative setting times of concrete. Suppose some concrete sets faster than 33 grade, so the pressure would be more or less. You understand it like this. There is a concrete 33 grade concrete, let us say its setting time is 20 minutes, or let us say it is 30 minutes, and let us say I am just giving you these rough values. 43 grade cement, let us say it gets set in, let us say 20 minutes itself. So, which one will be, suppose here it is P1, here it is P2. Okay. So, is P1 greater than P2 or P1 less than P2? Which one is correct? P1 greater than P2, because here you have more setting time, larger setting time. This is less setting time. So, larger setting time means more pressure, because it is liquid for for larger amount of time. This is less pressure because it has got set quickly, so it will not be exerting the lateral pressure. So, is this clear to you? Now, one more thing, when I showed you those curves, it was assumed that you have not used any admixture in your concrete. So, the curves are valid for no admixture. Those curves which have been shown to you are valid for no admixture, especially the retarders. But if you are using admixture, so depending on the setting time, you will have to apply correction factor. Suppose you are using retarder, then you will have to increase your pressure, because retarder will reduce the retarder will increase your setting time. Retarder will increase your setting time. If you are using accelerator, so pressure would come down, because now your concrete gets set quickly, so the pressure would be reduced. So, do you understand this admixture addition technology class? So, if I were to just quickly summarize Indian standard recommendations for computation of lateral pressure, it is like this. Indian standard gives too much importance to rate of placement, temperature, and that is why in its curve you will find rate of placement is on x axis and pressure on y axis, and the curve is for different concrete placement temperature. These curves are based on 33 grade cement concrete, 33 grade cement, 350 kg per cubic meter of cement content, no admixture, right? No admixture. What else? No admixture. Then you have medium degree of workability. Medium degree of workability. You had medium degree of workability. Now, if you are deviating from these base conditions, they have given you certain correction factor, which we need to apply in order to get the correct estimated lateral pressure. So, is this clear to you, technology class? Indian standard method you understand now? Okay. Now, we move on to lateral pressure computation based on DIN standard. So, the formula may not be that visible to you, I will just write it for you. This is basically based on DIN 18218, right. Now, they have specified 3 equations for maximum lateral pressure. P max is 21 plus 5 R. R is in kilo Pascal. This is for stiff mix. This is for stiff mix. On the other hand, P max is 19 plus 10 R. This is for soft mix. They have characterized different concrete mixes in stiff, soft and fluid mix. So, for this expression is 18 plus 14 R. So, these are the 3 expressions that have been given by DIN 18218 to calculate the lateral pressure being exerted on formwork. Now, all these curves are valid for 15 degree concrete placement temperature. So, the base condition here is 15 degree Celsius, right. Now, if there is an increase or decrease other than 15 degree centigrade, so they have given you a correction factor which says pressure must be decreased by 3% for every degree above, for every degree above 15 degree Celsius. Is it clear? So, if temperature has gone up from 15 to let us say 17 degree, so whatever pressure you have calculated, you increase it by 6%. It is like this. 15 degrees Celsius, 16, like this. So, for every degree increase you decrease by 3%. So, suppose for 15 degree you calculated 100. So, what would be the pressure corresponding to 16 degree? How much? 97. What would be for 17? 94. 3% of this, I mean 3 plus 3, 6% of 100. Is it clear? If you are decreasing the temperature, suppose 14 degree, so then this becomes 103. So 3% increase you have to do for every decrease in temperature by 1 degree. Is it clear? Okay, because your temperature affects the setting time, so they have conducted large number of experiments, and then they found that if you take this thumb rule, it should be all right. So they have all converted this into thumb rule, easy to use, so that you don't have to rely on too many complex equations, and still you are not suffering. So these are the 4 methods that we have learnt. In today's lecture, 3 methods: ACI, I have given you the formula for column, for wall, then Indian standard, we have discussed the curves specified by IS 14687, and then finally we have seen the DIN standard 18218 for computation of lateral pressure. So, do you understand all the 4 methods, including what we discussed in the previous lecture, Syria method? Do you have any doubt in that? Pardon me? T. This I forgot, but it's basically a German standard. Okay, so you can just search it on the net. I forgot its full name, but these are very stringent codes, especially followed by most of the reputed companies. DIN standards are supposed to be one of the toughest standards. So just find out its full name. I forgot it. Okay, but these are German standards. Okay. Okay. You remember FIDIC term FIDIC? So its expansion is also very complicated. Federation, engineer, D something. Okay, so it is also very similar to that. Of course, this is a different thing. This is different. So just on the net, try to find out the full form of DIN. Okay. Fine. So we have completed our discussion on lateral pressure. Remember we are discussing these under loads on formwork. If you remember one of the slides, I will just show you that slide. So that you know where are we. So if you just look at this slide, if you just look at this particular computer slide, remember we are discussing this loads on formwork. Under that, in previous lecture we had already covered dead load, imposed load we had started. Under imposed load, first thing we have covered, we have completed lateral pressure of fresh concrete. So, do you know where we are? We have just completed this lateral pressure part. I have shown you 4 methods to calculate lateral pressure. Now, we move on to the other types of imposed load. Other types of imposed load. For example, construction, personal, plant, equipment, vibration and impact of machine delivered concrete, unsymmetrical placement of concrete, concentrated load and storage of construction material. So, now we are trying to discuss other types of imposed load. We have already completed our discussion on lateral pressure. So, do you know where we stand? Where we stand in this chart? Remember, we are discussing the topic loads on formwork. In that, we have already covered dead load. We are in the process of covering imposed load. Under imposed load, we have already covered lateral pressure. We have learned 4 methods of calculating the lateral pressure. Now, we move on to the next type of imposed load, and let me just select that particular slide. Yes. So, here it is. Now, there is one standard ACI 347, American Concrete Institute 347 standard is there. If you see, it gives you a recommendation that formwork should be designed for a live load of not less than 2.4 kilonewton per square meter of horizontal projection. 2.4 kilonewton per square meter. It further recommends that if you are using motorized carts, buggies, you know, motorized buggies, they carry concrete and they run on the reinforcement itself to deposit your concrete. So, if you are using anything of this kind, then they recommend you to increase the load from 2.4 to 3.6. So, 2.4 kilonewton per meter square is for normal concreting operation. Remember, we are discussing live load, and this is as per ACI 347. If you are using motorized buggies, motorized carts for shifting of concrete, then in that case they recommend higher load. Okay. They also tell you that the design load for combined dead and live load, between should be 4.8 kilonewton per meter square for normal cases, and if you are using motorized carts, then it should be 6 kilonewton per square meter. You understand this? Live load is 2.4 for normal situation. It becomes 3.6 if you are using motorized carts. If you add dead and live load together, then in normal case it has to be 4.8, and if you are using motorized cart, it has to be, you have to take 6 kilonewton per meter square. Is this clear to you, technology class? Is that clear to you? Okay. So, these are the recommendations of ACI. Most of the formwork designer take recommendations from ACI 347, and that's why I thought of giving you this particular piece of information. So, if you are using the designing the formwork for normal situation, no motorized cart, use 2.4 kilonewton per square meter. If you are using motorized cart, use 3.6. Dead and live load put together should not be less than 4.8 in normal cases, and should not be less than 6 in case of motorized cart. So, that completes our discussion on imposed load. Now we move on to the environment loads. Environment loads, and you can see the various categories of environment loads displayed in this particular slide. Yes.
When you say motorized, do you mean pumpers and vibrators? Or
Not really pump and vibrator. Have you seen Tough Rider? Small dumpers which can carry about 1 cubic meter of concrete. So one, it has got maybe 1.5 to 2 meter length, and then there is a driver, and it runs on the reinforcement also. It is light but still with motor. If you just type motorized buggies or motorized carts, these were used in ancient construction, not ancient but old constructions, especially in USA, and even now they are being practiced. So just write motorized cart used for concreting. You will get some photos also in net. On the internet you will get some photos also. It is basically a small Tough Rider, a small dumper. Maybe it may carry about 1 cubic meter or half a cubic meter. So it is of that order. If you are using concrete pump, then you have to consider some dynamic loading also, because when you use pump, your formwork vibrates like this. If you just notice, your formwork support also vibrates like this, right? So that exerts little dynamic pressure, and for that you need to take some extra loading. So whenever you are using pumped concrete, use extra load. Okay, anything else?
so do you mean that the dumper is moving over the reinforcement?
Yes. On the reinforcement it is moving. So after you have placed concrete in one area, then you go on from one side pouring on, and it moves on the reinforcement itself. Of course you put some wooden planks, so exactly it is not running on reinforcement. It would be something like this. So you have a reinforcement mat here. Suppose this is the reinforcement mat. So you put some wooden plank here, and your vehicle is moving on this. So is this clear? These are your wooden planks. Clear?
Yes, please.
Okay. Any other doubt? Okay. Now coming back to this environment load, these are shown in this particular slide. You have different types of load, and depending on the situation, you will have to take care of these loads also. For example, wind loads, seismic loads, earth pressure, water pressure, snow and ice load, thermal load, and miscellaneous loads. Wind loads, normally if you are working less than 10 meter height, you do not need to consider, because these loads are very nominal. However, these wind loads would be very much predominant if you are working on a considerable height, maybe 20 meter, 30 meter, 40 meter. You will have to properly account for them. There are different codes for wind load, and just like you do permanent structure design, you try to do it here also. Do you understand how to calculate wind load, technology class? Have you calculated wind load? Have you considered seismic load? How to calculate seismic load? Is Ethiopia earthquake prone? Ethiopia, you have earthquakes? No.
Yes, yes.
Okay, so you know how to calculate the earthquake load. Before that, you know how to calculate wind load. Wind load.
No.
Okay, in wind load, uh, what is done is I can tell you the example of India. India has been divided into number of wind zones. Okay, so for each of these zones, they have calculated the basic wind speed. There is a term called basic wind speed. There is a term called basic wind speed. So entire country, if you see, they have divided it into number of zones, and for each of these zones they have calculated the basic wind speed. They call it as VB or VZ, whatever it is, right? And then they have certain coefficients. Basically these coefficients are nothing but the correction factors. So depending on the importance of the structure, depending on the terrain in which the structure is to be designed, all those things they consider while correcting this basic wind speed. Okay, so they have got the wind speed, and then they are able to calculate the pressure. There are certain formulas given in the Indian standards. Those formulas are used to calculate the pressure, and that pressure you take it for calculating the wind load. There is a separate code itself which gives you the details of wind load calculation in India. What is the normal wind speed at in, let's say, if you have to take an average in Ethiopia, or for that matter, what is the average wind speed in Addis Ababa? How many meter per second?
I'm not sure.
Okay, so just try to find it out. You try to measure wind speed today, okay? Then I will give you one code through which you can calculate at different height how much wind load would be coming. You remember just near that Gion Hotel, there is one large tower, large building. I think that is the tallest building in Addis. So you can climb on that and you can find out what is the wind speed. So you can calculate how much is the wind load coming at that particular height. Sometimes when you are constructing a very tall building, wind load would be more dangerous than your even earthquake loads. So they govern your design. So the critical factor would be wind load for very tall buildings. And in fact there are separate engineering itself, wind engineering. There you understand how the wind would blow, from which direction, how to take care of that. All those things become very important, especially when you are making a very tall building. Okay, but for your purpose, just try to calculate wind speed at the tallest building that you have, and then just estimate how much wind load must be coming. Okay, I will send you that code also. It's there is one separate code itself which gives you how to calculate the wind load. Okay. Similarly, there is earthquake load that needs to be considered if your area is in earthquake prone zone, seismic zone. There is again a separate code, so in which you they have given you the method to calculate the acceleration, and with that acceleration you can calculate the earthquake load that you can consider in your design. Similarly, if your formwork is against some earth fill, then it will again exert lateral pressure on the formwork surface. So, this you must be knowing, the earth pressure, active earth pressure, the passive earth pressure, you know, active earth pressure, passive earth pressure in soil geotechnical engineering. That you know. So, the same thing you will have to apply. Suppose your formwork is against some earth fill. Suppose this earth fill and you have a formwork. So, this will exert some pressure here also. So, how to take care of that? All those things come here. Then if you are doing some work inside the water, that also exerts pressure. So, water pressure. If you are having a problem of snow and ice in your locality, snow and ice loads are to be considered. Similarly, thermal load, if you are working in extreme temperatures where the fluctuation is very high, in those situations you will have to consider temperature loads also. So, these are some of the categories of environment load, and the computation of load is not something which you do it for formwork separately. It is almost in the same manner what you do for permanent structure design. So, whatever you have learned for permanent structure design, same thing, same concept you would be utilizing in order to calculate the various environment loads. For example, if you just see this particular slide, Indian Standard 875 part 3 gives you how to calculate the wind loads. If you are trying to design a formwork at a reasonable height, they say that okay, you have to take 3% of the vertical load, 3% of the vertical load as the horizontal load. So, suppose you have calculated 100 ton of loads, vertical load. So, take 3% of that in an horizontal as horizontal load for designing your structure, for designing your formwork, if you are not doing a rigorous calculation. Earthquake load, again you have a different code. Snow load, you have IS 875 part 4, snow load IS 875 part 4. Ice load, not relevant in India, I do not know whether it is relevant in Addis also. Ice loads, as you can see, they are required to be taken into account where you anticipate that ice would be formed. The thickness of ice deposits you can consider between 3 mm and 10 millimeter depending on the location. The maximum density of ice you can assume it to be 900 kilogram per cubic meter. Okay. So, this in nutshell I have given you I have given you some idea on different formwork loads. Okay. So, we considered dead load, we considered live load, we considered various environmental loads. We focused mainly on dead load and imposed load. In imposed load, there again we discussed primarily the lateral pressure, because these things only are different. You may not have studied them under permanent structure design. So, our main focus was to have a detailed discussion on lateral pressure, because that is more important in case of formwork. In the next class, we are going to see what is the design basis, what is the design basis for a formwork design, and we will also see some of the typical formulas for calculating bending moment, shear force and the deflection for different situations, single span, 2 span, 3 spans, more than 3 spans, because these formulas would be relevant when we start actual design problem. We will also take up 1 or 2 examples of lateral pressure computation. We will also learn how to create the pressure diagram, all those things in the next class. So, if you have any doubt pertaining to formwork design what we have covered till now, you may please feel free to ask. Thank you.
No doubt, thank you.
One announcement. On this Monday, I will not be taking class because I am going out for one examination duty. Okay, so Monday I will not be available. So my class on Monday will not be there. Thank you and good night.